Good morning, second grade friends. I am going to make this bigger and then we are going to get started. So yesterday I told you that we are going to work a lot with the number line this week, and we're going to work a lot on solving addition and subtraction number sentences or equations using the number line. Now, I want you to think back when we were doing fact families as part of our number corner. So that was last month when we had all the graphs. And then there was fact families that went along with the information that was inside the graph. Do you remember that? And I want you to remember that because addition and subtraction are what we call inverses of one another. You can take three numbers and add them and subtract them in different ways to get similar answers. So let's refresh our memory. I'm going to put the number 5. I'm going to do our house. And I'm going to show you what it looks like. I'm a little bit bummed because when I use this little small camera in the corner, it doesn't flip it the right way for you. So you really have to listen along with watching the video so you know what I'm talking about. Okay, so I did my house. And the numbers I'm going to do are 8, 5, and 3. So 8, 5, and 3. Let me make my bubble a little bit bigger. All right, so when I say a fact family, it means that I can use those three numbers to make 2 addition number sentences and 2 subtraction number sentences. And I want you to remember this because sometimes the way that you look at a story problem, even if it is written like a subtraction problem, you can look at the numbers in a different way and make it an addition number sentence. Because I know, at least for me, it's easier for my brain to think addition than it is subtraction. All right, so here we go. If I have 8, the first 2 addition, this is going to be backwards, but the first addition is I can do 5 plus 3 equals 8. Okay, I can also do 3 plus 5 equals 8. Okay, and then I'm going to erase those real quick so I have room. For my 2 subtraction problems, I always have to start with the biggest number in subtraction. So I have an 8 and a 5 and a 3. Which one of those numbers is the biggest? The 8. And so both of my subtraction equations are going to start with that number. So I'm going to have 8, 8. 8 minus 5 equals 3. This marker is not the best. And then 8 minus 3 equals 5. All right, so let's talk a little bit more about how we're going to do this. All right, so we're also going to be looking at height and length, and that is something that we've talked about a little bit in the past. But I know that now, being an adult, I do my most adding and subtracting when I'm trying to measure things, especially for my house. Like I need to know if something's going to fit inside my house or if a couch is going to fit in the living room. And so we're going to look at the height and length problems and using addition and subtraction. You might also measure yourself to see how tall you are or how much you grew. Those are other things that you might use. All right. Let's see if it will go to the next one or if okay. So here's a problem. I just want you to listen to it and we're going to think, what parts do we know? So we've been talking a lot about start, change, and end. Well, that can be the same for addition and subtraction problems. So I'm going to go ahead and write my equal sign. But we're going to leave this part blank for right now. So I'm not going to write a plus sign or a subtraction sign, minus, because I'm just going to listen first. And I'm going to think about the numbers that I know, how I would want to write it, and then if I can write it in a different way. So let's see. David is 49 inches tall. His big brother Matt is 76 inches tall. How many more inches will David have to grow to be as tall as his brother? David is 49 inches tall. His big brother Matt is 76 inches tall. How many more inches will David have to grow to be as tall as his big brother? Okay, so I'm hearing that this is a subtraction problem. So I'm going to go ahead and add my minus. All right. Now let's think a little bit more. I know that when I'm subtracting, I have to put the big number first. So I want you to look at this number sentence and not the number sentence, the story problem. And what is the biggest number? Is 49 or is it 76? I think that 76 is bigger than 49. So that 76 needs to go first. So I'm going to go ahead and write that in. Okay. So Matt is 76 inches tall. David is 49 inches tall. And I want to know how many more inches or how many more inches David has to grow. So I'm going to take how tall Matt is and subtract how tall David is right now to figure out how many more inches David needs to grow. So I'm going to plug that 49 in. All right. So then let's think about this. How can we turn this into an addition problem when we think about our fact families? So you could keep it like this, but like I said, I like to think of things like addition. So I'm going to tell you that when you have a subtraction problem, this first big number right here, I'm going to turn up your listening ears. This first big number in a subtraction problem, if you look at it in an addition problem, it's the target number. So the first number in a subtraction problem is the target number in an addition problem. I'm going to say that one more time. The start number in a subtraction problem is the end number in an addition problem. So I'm going to rewrite this because I want to use my number line. And instead of going backwards on my number line, I want to go forwards. So I'm going to take that 76. So I'm writing my number sentence again. Or I'm writing my boxes. Okay, so here we go. My start number in a subtraction problem, if I'm thinking about fact families, will become my end number in an addition sentence. So I'm going to go ahead and put this here, 76. My start number in a subtraction problem will become my end number in an addition problem. All right. Now, I still know another number. What other number do I know? I know this 49, right? So it doesn't really matter. I'm going to put it in the start position. So I know that this is how tall David is right now. I know that this is how tall David would need to be as tall as his brother. So I want to know how many more inches David would need to equal 76. Do you see how that's working? So now this looks like what I've done before with my number line. I have my start and I have my target, and then this is my jumps. So I'm going to go ahead and do that. I'm going to draw my number line. And remember, I know that it's backwards for you, so that's why it's important for you to not only listen, but to also think about what you know about number lines and fill it in from there. Okay. So I have 49 and 76. Now remember, I can take hops of 1 5 and 10. I like to get to an anchor of 10. So if I'm at 49, I want to get to the closest group of 10. So remember, groups of 10 are 10, 20, 30, 40, 50, 60, 70, 80, 90, all the way forever and always. But which group of 10 is closest to 49? Is it closer to 40 or is it closer to 50? It's closer to 50. So I'm going to take one hop of 1 to get to 50. Now remember, when I'm on my number line, I need to label my hop and where I land. So I'm going to label that as 1, and I landed on 50. So it looks just like that. 1, and I landed on 50. My target's 76, and I'm not there yet. So now I'm going to start taking hops of 10. So I'm going to take a hop of 10. I'm going to label it. So I'm going to label my hop, and I'm going to label where I landed. I was at 50, so now I'm at 60. All right, I'm not there yet, so I'm going to take another hop of 10. All right, I'm still not there yet, so I'm going to take a hop of 5. Oops, 70. There we go. Now I'm at 75. Hop of 1, and I'm at my target. And then I can add up my hops to figure out how many more inches David needs to grow. So I know 10, 20, 25, 26, 27. So I can plug it in 2 places. I can plug 27 in here. 49 plus 27 equals 76, but I can also plug it in here. 76 minus 49 equals 27, because addition and subtraction are the inverse of one another. All right. So so there is the same example of how you can do both. Now again, you can do subtraction problems and go backwards, but it's just a little bit easier to think of it as addition. And what we know about fact families, you can use it for your story problems that you solve. Okay. Whoa. So here are 2 that I want you to work on by yourself. So you're going to solve these. I will get us started. And then after you solve these on your own, you are going to make a choice board choice. They're the same 4 choices all week long. All right, so there's 2 problems. There's number lines already for you. But remember, if you're at home and you don't have this paper, this is easily drawn in a notebook. So here it says, use an open number line to solve each of the problems. Be sure to label your work and show the answer. All right, so number 1. Little Inchworm is going to visit her grandma. Her grandma lives 82 inches away. Little Inchworm has already crawled 47 inches. How many more inches does she have to crawl? So same as before, I'm hearing a subtraction number sentence or a story problem. So I'm going to show you what I hear, and then we're going to just quickly think about how we can make it an addition problem to make hopping on a number line a little bit easier. Okay, so I've drawn my boxes. I'm hearing a subtraction problem, but let's see. Okay, Little Inchworm is going to visit her grandma. Her grandma lives 82 inches away. Little Inchworm has already crawled 47 inches. How many more inches does she need to crawl? Okay, so I'm going to plug that in. Grandma lives 82 miles away. Inchworm has already crawled 47. So that's what a subtraction one would look like. But remember, I told you that the start of a subtraction problem is the end or the target in an addition problem. So which number would I move here? the 82. So the start of a subtraction becomes the end of an addition. And then I can put this guy in my start place. So 47. So you could read it this way. Little Inchworm has already crawled 47 inches. His grandmother's house is 82 miles away. How many more inches does he need to crawl? Okay, so this would be your start on the number line, your end, and then this is counting your hops. Okay, now for number 2, so I would right now, if you haven't, I would write this down. I would make your number line on your piece of paper, just like they have it here, right? Oops, 47. And then do your target of 82, and then figure out what kind of hops you're going to take. Hops of 1, hops of 5, hops of 10 to get to that target of 82. Okay, remember you need to label your hops and where you land on the number line. All right, then the next one, I'm just going to read it, and then I want to see if you can do it all by yourself, figuring out how you could take the subtraction equation and turn it into an addition problem. All right, we have 2 jump ropes. The red one is 120 inches long. The blue one is only 84 inches long. How many inches longer is the red rope than the blue rope? Okay, so think about, I'm going to get you started, but think about how your start, change, and end are going to change based on subtraction or addition. So remember, your start for subtraction becomes your target for an addition. And your start for a subtraction is always, always, always the biggest number. Okay? All right, good luck. I know that this is something new and it might be a little bit hard, but I know that you can do it. I have all the faith in the world. And I know that the more you practice, the easier it will get. So I hope you have fun. I hope that it's at least clicking a little bit. And like I said, we will be practicing this all week long. So if you're feeling a little bit overwhelmed, take a deep breath. I know that you can do it. I know we will get better. I know that this can be a strategy that you use all the time. All right, go and solve those 2 problems and then make a choice board choice. See you tomorrow.